HashiCorp Vault is the prominent secrets management solution today. It is currently used by top financial institutions and enterprises in the world. Hi, my name is Sam Gabriel, and I've been working in IT for over 15 years. My focus now is on all things DevOps. I'm a senior solutions engineer at HashiCorp, and I'm also a HashiCorp Vault associate. I constantly produce content in the DevOps space in the form of blogs, YouTube videos, and courses. And I've created this Vault Fundamentals course for you. This is a 1-hour course, which is a subset of a much larger course that is 8 hours long, called HashiCorp Vault 101 Certified Vault Associate. It will help you dig deeper and be ready for the Vault Associate exam. You can find this course by going to courses.techinaid.com and scrolling to the bottom of the page. And I'll also drop a link to this course in the lecture's description. Okay, let's get back to our Vault Fundamentals course right now. In this course, you'll learn the following topics. What is HashiCorp Vault? Vault use cases, basic Vault CLI commands, Vault server modes, Vault architecture internals, Vault seal and unseal, the configuration file, how to run a production Vault server lab, authentication overview, types of auth methods, policies overview, tokens overview, secrets engines overview, replication design with disaster recovery and performance replication, that's DR and PR, and finally Vault agent overview. I hope you enjoy this course. What is HashiCorp Vault? Well, it's a cloud agnostic secrets management system. And when we say cloud agnostic, this is true for all HashiCorp products. The idea is HashiCorp sets out to create a control plane that is above the different platforms that's going to work on. Basically, you can have a secrets management solution like Vault, and you can store secrets across multiple locations and platforms, data centers, clouds, and so on. So when you have a hybrid cloud solution, you might have secrets on premises, you might have some secrets in one of the clouds or multiple clouds like GCP, AWS, Azure, and VMware, for example, and you want a centralized solution that can go across all of those clouds. Vault is API driven. Everything in Vault runs through the API. So if you want to interact with Vault through the CLI or even the UI, that will go through the API. It allows you to safely store and manage sensitive data in hybrid cloud environments. We touched on that. And also, it's used to generate dynamic short-lived credentials. It also encrypts application data on the fly. You'll notice me say this quite a lot, that the value of Vault is moving away from static, long-lived credentials to more dynamic, short-lived credentials. Very key to understand that point. All right, what's a secret? Let's identify what a secret is. So below are some of the most common types of secrets: usernames and passwords, certificates like PKI certificates, SSH keys, API keys, encryption keys. And one thing to note here that I want to bring up before we move on is that managing secrets is not an easy task for IT engineers in large enterprises, because secrets can live in many different locations. So it's not easy to figure out who owns what in those different locations. And a lot of I'll read this report for you that US CEOs place cybersecurity as their #1 business worry, really ahead of new competitors and even ahead of the recession. So in the last 10 years, 20 companies have experienced massive data breaches costing them over $1 million. And a lot of these were because of lack of management of their secrets. That's why Vault is very important, and it's really crucial to know the state of all the secrets in your environment. Where do they live? Who owns them? Have proper auditing mechanisms in place. Vault helps with all of that. So what problem does Vault solve? We kind of touched on that really quickly, but we'll reiterate. Secret sprawl. And below are some of the common examples where you can find secrets get stored. Sometimes on a developer's computer, in an Excel sheet, in a notepad file. scale that out to hundreds, even thousands of employees in a company. That becomes a problem. Who owns them? Where do they live? They also can live in basically hard-coded in the source code itself. Many developers forget, like they will hard-code the secrets there, and that's it. That's where they live. They could live in a sticky note under some engineer's keyboard. I've seen that. I've seen that before. Some people will not admit it, but it's happened. These secrets can live in a version control system like GitHub or GitLab, and sometimes these systems get exposed publicly, and some of those breaches were a result of that. Hopefully this gives you an overview of what Vault is, what secrets are, and the problem that we're trying to solve with Vault. So the first use case is secrets management, and we kind of touched on this a little bit earlier, but basically storing secrets centrally inside of Vault and consuming those secrets by humans or by machines. So the idea of centrally storing those secrets and then distributing them to humans and applications. The second use case is encryption or encrypting application data. So the idea here is keeping the application data secure and centralizing the key management for the encryption keys inside of Vault. The third use case is identity-based access, and this is the idea of making Vault a broker of identity so that you can authenticate inside of Vault, and that will give you the ability to authenticate into different clouds and system endpoints, again via Vault. Now let's take a few examples, one example per one of those use cases. So we'll see 3 examples. The first one is with regards to secrets management. So the KV secrets engine, and we're going to get into a lot more details when we get to the secrets engines section in this course. But for now, to give you a quick overview, a client could be a human or it could be an application. And the idea is to retrieve a secret from Vault. So the client makes a call into Vault at a specific path, and everything in Vault is path-based. So for example, here we're going to talk to Vault at kv/secret/foo. We present a token to Vault, and we'll talk all about tokens later in this course. This token is associated with something called a policy, and this policy is the authorization mechanism into Vault, which basically tells Vault whether this token and the owner of this token is allowed to retrieve the specific secret at this specific path, whether they're allowed to read it or write or create and so on. So in this case, they're allowed to read the secret at the path secret foo in the KV secrets engine. Vault will respond back with the actual value of the secret, which is secret here. So foo is the key and the value is secret. And that's why we call it a KV secrets engine. It's a KV pair where we're storing statically those secrets in that engine. The next use case was encrypting application data. And in this case, we're going to take a look at encryption as a service, which is also called the transit secrets engine inside of Vault. In this case, a web server wants to encrypt some data, so it's going to pass some plain text over to Vault at a particular path, again at the transit/db path. Pass the token into Vault. Vault checks that token's policy to make sure that this web server is allowed to access that particular path. Vault's going to respond back with encrypted data, so that plain text is now encrypted. It's ciphertext. As you can see here, it starts with Vault:v1, which is the first version of that secret using the first iteration of the key, and some blob of text. Basically, the web server now can store this encrypted data inside of a database, let's say a MySQL database, and therefore if anybody accesses this database, this data is encrypted at rest and they can't really see anything. Now, Vault will not store the actual ciphertext or the plain text for that matter. That's why it's called the transit secrets engine. but it's going to pass it back to the requesting client. And then that's up to the client where to store that ciphertext. It could be in a database like this case, or it could be in an S3 bucket in AWS, or on premises on a file system somewhere. So that's the second use case. Let's take a look at the third use case. As an example here, we're going to use the dynamic AWS secrets engine. And what we'll do is we have a client once again. This client wants to talk to Vault. So it passes its token with a particular path, AWS/prod1, for example. Vault's going to check the policy that is associated with that token. And if that client is authorized, it's going to create credentials inside of AWS. And basically AWS will come back, give it the access and secret keys, which Vault will pass back to the client. And at this point, the client has access into AWS. Once again, whether this client is a human or a machine or application, it doesn't really matter. This client will now have access to AWS. So basically, Vault is brokering the access into AWS. And for this lecture, we're going to focus on the basic Vault CLI commands. We saw earlier when we installed Vault that you can just type Vault by itself and give you a list of Vault CLI commands. Mostly these are the common commands that you can start off with. So you can see here when you type Vault, it gives you the usage. You can type Vault followed by a command, followed by some arguments. And here are the common commands. So you can see read, write, delete, list, login, agent, and so on. We also saw Vault version before, and that tells you the version of Vault that you're running. Vault read typically is used to read secrets from Vault, whereas Vault write is used to write secrets to Vault. The -h or -help or -help flags are very important. They're used to get help from the Vault CLI command. So they could be used at different sub-commands as well. So as you get deeper into the commands, very helpful. I use it all the time. So I encourage you to test it and try it out. So why don't we get started and run some of these commands hands-on. Okay. Let me make this a little bit bigger so we can see well. Okay, so let's just start off with typing Vault, and as you can see here, get a bunch of common commands that are used. I also want to show you again Vault version, very important command. That will show you the version that you're running right now. It's clear. And you can also use Vault-H, gives you the same thing, Vault-help, or even Vault-help. That works as well. Now, you can go deeper into the command structure. So if you say Vault secrets -h. Now, if you notice, it's showing you the usage is Vault secrets, then a subcommand with some options and arguments. And it gives you an example. So if you want to do Vault secrets list, Vault secrets enable database, and so on. So these are the subcommands: disable, enable, list, move, and tune that you can run. All right, let's take another example, and you can type Vault read -help this time, which will give you an output that's specific to this subcommand Vault read with some options, and then you need a path. And here's an example: Vault read secret -my secret. So we're reading a secret here at this particular path. And there are options here as well, so you can specify a flag address with the actual address of where the Vault server lives, and we'll see later that we can also define environment variables to do that as well. and so on and so forth. So take some time, read through this, understand what the different commands do, and feel free to experiment. And also finally, if you look at the output options, you can have a field, so you can specify certain fields to show, which is very helpful when you're running CI/CD pipelines and you want some answers back from Vault that you can reincorporate in your pipeline. Also, from a output perspective, you can format the output in terms of a table, which is the default, JSON, YAML, or pretty. That also gives you better outputs that can be used in your pipelines for automation. In this lecture, we're going to talk about Vault server modes. So let's get started. Alright, so Vault has two modes to run in. The first one is called Dev mode, which is only intended for development. That's where the name comes from. Second mode, you guessed it, is Prod mode. This is where you're running in QA or production. As you can see here, we are trying to get some help for the Vault server dev, so vault server-dev-help, and it will give you some options as to what to do in dev mode. So you can see this option, for example, is what we're going to run in the hands-on, which will allow you to use root, the four-letter word root, as your default root token. And we'll see how that works in just a little bit. So a few notes on Vault's dev mode. It is not secure. It stores everything in memory. So once you shut down your machine or you stop the Vault process from running, everything is gone. The configuration is gone. The secrets are gone. It's automatically unsealed when you run the Vault server dev command. And we'll learn a little bit more on sealing and unsealing later in this course. But think of it as you can't do anything with Vault in a sealed state. So just as a bank vault, if it's sealed, you can't really get anything out of it. So you can only interact with Vault when it's unsealed. The root token can be specified before launching, and that's what we just mentioned and we'll do in the hands-on. So in red bold letters here, please do never store actual secrets in Vault when it's running in dev mode. This is just to test. I use it all the time. So if I want to test a new version of Vault, some new feature that came out, some commands that I want to try out, very handy to spin up a quick Vault server and run tests against it, but definitely not to be used in production. Why don't we run some hands-on commands and see how that works. Okay, so I'm in my terminal. And first thing is to run Vault server -dev. And I'll show you just a quick help summary because there are many commands that you can run here, as you can see. But the one that I use the most is at the very bottom, dev root token ID, where you can specify the actual token. Because if you run Vault server dev just like that, it will start the Vault server and it's going to give you unseal key, an unseal key, and a root token. This root token and unseal key are automatically generated, and I don't really want to have to memorize this thing when I'm doing testing or have to save it somewhere in a notepad file or whatever. So I usually like to run Vault with this flag here. Let me just clear it so you can see better. I like to run Vault with this flag here, dev root token ID, and you give it a name. I give it any name. In this case, I'm just calling it root to make it simple. Hit enter. Now Vault is running as a server in dev mode, and I can start to interact with it. It is automatically unsealed. So what we do is we can open a new terminal, and once again, let's make it bigger so we can see well. Alright, so we're going to start interacting with Vault. The first thing you want to do is create an environment variable called Vault address, and this will be the address of the Vault server. which is running on my local host on port 8200. And if you go back to that terminal, it shows it to you right here. So we could have just copied that and pasted it in the other terminal. But basically, once you do that, you're telling the Vault CLI where to find the Vault server so you can interact with it. Cool. First thing I want to do is check the status. And you can see the sealed type is Shamir, initialized is true, and sealed is false. That means it's unsealed. And again, because it's in dev mode, it's automatically unsealed. We can see the version here of Vault that is running. It's not running in an HA state, which is all good. Now the next thing is we need to log into Vault. So I can type Vault login. It's going to ask me for a token. Remember, it was root, so R-O-O-T, enter. Success, you're now authenticated. And you can see the capabilities of my token. So it's root, this is the super user. I can do whatever I want. It's tied to a policy called root. We'll get into policies later on and tokens, so don't worry about it. Just know that I'm in super user mode right now, and I can do whatever I want. But again, this is in dev mode, so I'm going to destroy it afterwards. Doesn't really matter. This is just for testing. Okay. Now, let's start writing our first secret. And for that, we're going to use the KV store. And I'm going to run a help command on Vault KV. And you can see some of the subcommands for Vault KV: delete, destroy, get, list, patch, put, undelete. It's a bunch of commands that I can run. And it's very good because it gives me some examples that I can work with. So you can see this Vault KV put secret foo. Again, it's a path. And the actual secret, the key value is, the key is bar, and the value is his baz. So I can go ahead and run that. But I can take this a step further to show you that I can go deeper in the help menu. So I can say Vault KV put -- help. And it will give me, again, a help menu. So let me scroll to the top. And sort of the same thing here. So I'm going to just copy that command. And I'm going to clear. So notice Vault KV put secret / foo bar = baz. So I am writing a secret at this particular path, which is bar = baz. So let's do that. Hit enter. And you can see that the version of the secret is version 1. It's creation time. There is no metadata. There's no deletion time. It is not destroyed. It is active. Everything looks fine. And by the way, we'll get into this later when we talk about secrets engines, and particularly the KV version 2 that we're running right now. Just note that in dev mode, the secret path is enabled by default for the KV secret engine, so you can run tests directly on that path. Okay, so we wrote our first secret. Congratulations, good job. Now let's go ahead and look at how to maybe update this secret. So I can run something like KV Vault KV put secret foo, and I can keep bar = baz, but maybe run hello = world as well. So this is another secret that I'm putting in here. The key is hello, the value is world. Okay, let's hit enter. Now notice something here. Now version is 2. We moved from version 1 to version 2. Okay, very good. So I have secrets versioning. I can have multiple versions. So that's great. We've updated a secret. Now let's go ahead and read that secret back. So let's clear this. And once again, run Vault KV. In this case, to retrieve a secret or read a secret, you do Vault KV read. Vault KV get secret foo, which is the path where we stored that secret. And right away, we get some metadata around the secret. So the creation time. We can store some custom metadata as well deletion time destroyed is false, version is 2, and we've returned the recent version of the secret, which is version 2, and you can see the key values that I have here, bar baz hello world. Good job. So we've been able to write a secret, update a secret, read a secret. Let's see how we can delete a secret. And to do that, you can just run vault kv delete. Again, specify the path where the secret lives. Success, it's been deleted. Well, let's verify that and try to get the secret again. And right now, you only get back metadata. There is no data as we saw up here. So no data associated with the secret anymore. It's been deleted. However, destroyed is false, meaning that I can actually undelete this secret and get it back, which is really cool in case I make a mistake. So let's see how we can do that. For that, we can run the command vault kv undelete versions equals 2 secret foo. So I'm undeleting this version equal 2. Perfect. Now let's run the get command again. And there you have it. We were able to retrieve our secret. We were able to undelete it and get it back. So this is very handy in case we make a mistake. We can always undelete it. There is a destroy command, and if we run that, that will effectively permanently delete the secret. We won't be able to delete it. I'll leave it up to you to explore that one and test it out for yourself. When we look at Vault, there is the core of Vault, there is the API, and in a previous section we talked about how interfacing with Vault is always through the API, whether you use the UI or the CLI or even directly the API. There's also the storage backend, and finally the cryptographic barrier that surrounds the core of Vault. So there's a clear separation of components that are inside or outside of this security barrier. And only the storage backend and the API, as you can see, are outside of this barrier. And the storage backend, think of it as it's untrusted, and Vault doesn't really trust whatever type of storage backend you use. This is pluggable, so you can use all kinds of storage backends, but it's not trusted by Vault. Vault, when it starts, it's provided with a storage backend, and the data in there is available across restarts. But of course, the data is encrypted on that storage backend. Similarly, the HTTP API must be started with Vault, and the clients interact with it. So we talked about, the UI, the CLI, and the API. So that's your interface into Vault. Now, this is a very simple picture of the internals of Vault. If we want to get a little bit more deeper into the architecture, you can take a look at this picture from the documentation from HashiCorp. And throughout the remainder of this course, we're going to look at this picture many times as we tackle the different components. So as you can see, the HTTP API is at the top, storage backend is at the bottom, and in here is the core, and there are multiple components here, and this is within the cryptographic barrier that we just talked about. So as I mentioned, in this course, we're going to look at all these components. So stay tuned, and hopefully this lecture helped you kind of get an overview of the internals of Vault, and I'll catch you in the next lecture. When Vault starts up, it starts up in what we call a sealed state. So similar to a bank vault, it's completely locked down, can't do anything with Vault. And the only thing that Vault can do is actually access the physical storage. So the underlying storage backend here, it has access to it, but it cannot decrypt it, can't get any data out of it. So no operations are possible with Vault except to unseal the Vault and check the status of Vault. Very important to note this. Vault data is encrypted using something called an encryption key in the keyring, and the keyring is encrypted by something called a master key, and the master key is encrypted with an unseal key. So to visualize this a little bit, I'm going to talk about a shared Shamir set of keys, and in the next slide we'll talk about Shamir in more detail. But think of it as a way to split up a specific key among multiple stakeholders, and these custodians of the key, if you will come together to create what we call a combined key. And inside the storage backend, we have a master key that is encrypted, and we also have a key ring that is also encrypted. So if we go back to this bullet point, it'll make a little bit more sense. Remember, the data in here inside of Vault is encrypted with the key ring, with the encrypted key in the key ring. And then we're protecting this key in the key ring by a master key, and we're protecting the master key with the unsealed key, which is the combined key, basically, when you bring together the shared Shamir keys. So multiple levels of protection here, as you can see. So let's talk a little bit about unsealing with Shamir, because this is the default mechanism for unsealing Vault. And basically, it's an algorithm to split the keys into shards. And a certain threshold of shards is required to reconstruct the unsealed key, which is then used to decrypt the master key. Shards are added one at a time in any order until enough shards are present to reconstruct the combined key. And the operation to do that, you basically need to run vault operator unseal. That's the command on the CLI, or you can do that also via the API. And you also can do it with the UI. One thing to note, out of the box by default, Shamir unsealing will require or will give you 5 keys, 5 shared keys, so 5 shared Shamir keys, and a threshold of 3 by default will unseal Vault. And a best practice is to make sure that those 5 keys, when you create them, nobody gets to see all 5 in the same place. So there are mechanisms to do that using PGP and so on. Well, basically, you're going to have custodians of those keys in different departments of the organization that when they come together, that's when they're able to unseal Vault. Let's talk a little bit about sealing, the process of sealing, and that is done using the command vault operator seal. And sealing, what it does, it removes the master key from memory, and it requires another unseal process to restore it. All right, so once we seal it, that's it. The master key is removed from memory, Vault is locked down. It's, of course, stored encrypted in storage again. And if you need to unseal, you'll need to go through the whole unseal process once again. Sealing requires a single operator with root privileges. So unlike unsealing, when you needed the unseal key or maybe the shared keys to come together to unseal Vault, to seal Vault, you just need one person with root privileges. And reason for sealing, for the most part, it's kind of a break glass where you just wanted to lock down everything. Maybe there's a detected intrusion and you need to minimize damages. You want to lock down Vault. So that is the main reason for it. And once a Vault node is unsealed, it remains unsealed until one of the following events happen. So until it's resealed via the API, so somebody reseals it, or the server gets restarted, and or the Vault storage layer encounters an unrecoverable error. So these are the 3 main reasons why you would have Vault go back into a sealed state. The server restarted is a very important one that you need to keep in consideration. If you're restarting the server for any reason, maybe the VM that it's running, that Vault is running on, or the actual Vault service itself, you got to make sure that you have proper mechanisms to unseal it. Which brings us to the next topic, and this is auto unseal. So auto unseal reduces the operational complexity of keeping the unseal key secure. So what we do with auto unseal is we use a cloud service or an HSM, hardware security module, And what that's going to do for us is going to automatically unseal Vault for us. Instead of having the custodians of the keys and maybe somebody, maybe Vault got sealed for some reason, it's in the middle of the night, and now you have to wake up a few people across the organization, bring them together to unseal Vault and bring it back to become operational. A lot of headaches. So in most production environments, folks opt to use the auto unseal mechanism. So it delegates the responsibility of securing the unsealed key from users to a trusted device. It could be an HSM or a trusted service like Google or Azure or AWS to do that process for you. So the way it works at startup, Vault will connect to the device or service implementing the seal and ask it to decrypt the master key that Vault read from storage. Remember, the master key is stored in storage. Vault will grab the master key, ask the service or the HSM, the cloud service or the HSM, hey, please can you decrypt the master key for me? And it'll go ahead and do that. A couple things to note: when you're initializing Vault with Shamir, you end up with unseal keys. When you initialize Vault with auto unseal, you end up with recovery keys. So the reason for unseal keys and recovery keys is also that there are some operations, such as generating the root token, that requires the unseal keys in the case of Shamir, or auto unseal in the case, recovery keys in the case of using auto unseal. So that's it for this lecture. Hopefully you got a good understanding of sealing and unsealing of Vault. We'll see a lot more when we start doing some hands-on with Vault. Thanks for watching. Let's get started with the configuration file. So running a Vault server in prod mode requires you to have multiple steps. Remember, we're moving away from dev mode, now we're doing prod mode. Okay. So the first thing is to specify the configuration file and write the config in there. Then you got to start the server, and then you need to initialize that server. And when you initialize the server, you get two things. You get the unseal keys and the root token. Then you unseal the Vault with these unseal keys, and now you can start to interact with Vault. So the configuration file. So production Vault server gets its config from this configuration file, and you can see an example here. This is the config file that we're going to use later on in the lab. This config file can be specified in HCL or HashiCorp configuration language or in JSON. And to run a production server, you can use this command vault server-config and then the path to this configuration file. And notice here we're not using the flag -dev. Well, that's pretty much it for this lecture, and I will see you in the next one. In this lab, we're going to run a Vault production server. So let's get started. And for this, I am going to use my favorite IDE, and this is Visual Studio Code. If you don't have it, I highly recommend to download it and use it. It's cross-platforms. You can use it with your Linux system or your Mac or your Windows. Highly recommend it. And we're going to get going and take a look at the lab guide, and we're going to do it step by step, all the commands. So let's get started. Alright, so start the Vault server with a config file. So the first thing I want to show you is the configuration file that we have. And over here, the Vault config file. This is what it looks like. The very first piece is the listener. We're listening on all addresses at port 8200. TLS is disabled just for demo purposes. You typically don't want to do that. We're going to use the Raft storage backend, my favorite backend, as I mentioned in a previous lecture, and a path where we're going to use that, and that's the Vault data in the current directory. Node ID, give it a node name. We're going to call it node 1. Remember, you can have multiple nodes in a cluster, so giving it a node number is important, or a node ID. Also, disable mlock is true. Now, you don't want to do this in production. What mlock is, it's a system call, and it prevents memory from being swapped to disk. In production, you don't want that to happen from a security point of view. Since Vault runs everything in memory, you don't want to have anything get written to disk. So you want to make sure that disable mlock is false, which is the default. And finally, we have the API address, the cluster address, and then the UI is true because we want to take a look at the UI as well. All right, so let's continue with our lab. All right, first thing we want to do, we want to change directory to our lab, so section 6. And I want to create a new directory where we're going to store, this is for our backend storage. Okay, perfect. And then, let's clear this. We are going to run vault server config equals to our config file, which is vault-config.hcl. Hit enter. And this is going to start our Vault server. Now let's take a look and see what logs we've got. API address, as you can see, the cluster address. We're listening on port 8200. Vault 1.9.3 is running. We're using Raft. It's highly available. And that's it. We are running Vault. Perfect. And this is a production Vault, unlike the dev Vault cluster we saw before. All right, so now the next step is to initialize the Vault. So we can do that by opening a new terminal window. And we're going to export the Vault address. This is the environment variable, so our Vault client can now know where to find the Vault server. So localhost port 8200. Perfect. And first thing I like to do always is to run Vault status. Make sure that I'm able to connect to the Vault server. So I get back initialized false. That means the server hasn't been initialized. Sealed is true. Vault is sealed. I don't have any total shares for the keys or the threshold of the keys or anything. So we need to initialize Vault. To do that, we're going to run the command vault operator init. And I'm going to say key shares equals to 1 and key threshold is also equal to 1 for demo purposes. This is going to run Shamir. It's going to initialize with Shamir. I don't want to have to, every time unsealing Vault for running demos, to have enter the unseal key 3 times. So once is enough. And this is what you get, which is very important to save your unseal key and your initial root token. The next step is going to be unsealing the Vault. But before we do that, let's copy that and go ahead and save this. I have a file here I call secrets, and you can save it in here and make sure it's in your git ignore file for Git, so it doesn't get pushed into GitHub or GitLab. Of course, I'm going to destroy this cluster after the recording, so it's not a big deal if you see it. If you see the credentials, that is. So once we've saved that, let's go back to our lab. And after we've initialized Vault, we now want to export the Vault token so we can communicate with Vault. So let's clear this. Export Vault token equals, and that should equal our token that we just copied, this one here. Save that. Perfect. Let's go back to, now the next step is to unseal Vault. All right, so I need to run this command, vault operator unseal. It's going to ask me for the unseal key. So let's go back and grab that from here. enter. And we get an output here. It tells me that initialized is true, sealed is false, so it is unsealed. Total shares of the key is 1, threshold is 1. Everything looks good. We are good to go. If I run the vault status command, it should give me the same thing as you see here. And that's perfect. Raft is working well. HA mode is active. HA is enabled or true. Everything looks really good. Perfect. Let us continue with the lab. All right. We've unsealed Vault. We've checked the status. Next is enabling audit logging. Let's see how we're going to do that. So I need to go back into my proper folder, and let's create let's just clear this. Let's create a directory called logs, and we can type vault audit enable file path equals to logs vault audit.log. Okay, let's go ahead and do that. Success, enabled the file audit device at file. Let's open a third terminal and run this command to basically take a look at the vault. Of course, I gotta get back into my proper directory, section 06. Let's run that command again. And there you have it. We are looking at the audit logs for Vault. So let's make it a little bit bigger, and you can see here the path, sys audit test, and so on. So keep this running when you're playing around with Vault. You can see the different logs that are coming back out here. We're going to see a lot of this later in other sections. We might not focus on the audit logs, but if you have this running while you're making some changes inside of Vault, you can kind of take a look here. Now you could also log into the Vault UI, so you can go ahead and go into a browser window, go to 127.0.0.1.8200. That should connect you to the Vault server that's running on your computer. And what we're going to need for this is the root token. So why don't we go ahead and grab that while this loads. Let's go back to our secrets file, grab our root token, go back to the UI, and it's still loading. There we go. Token method. The way we're going to authenticate here is with the root token. There's a whole section on authentication, so don't worry about that. But just know that we are now in the UI. You can do all kinds of things in here. You can enable a new engine. So feel free to take a look. We're going to discuss the UI and do a lot of things with the UI later on. But now you can see that you have access to the UI. And if we go back here, you'll see that the audit logs are also updating as we're doing things on inside of Vault. So hopefully this has been helpful. Thanks for watching, and I'll catch you in the next lecture. Let's take a look at an overview for authentication. So back to our architecture diagram, you can see where authentication methods lie. And there are many available authentication methods. We're just going to tackle the most popular ones. And here is a snapshot from the UI where you can select an authentication method to work with. So let's take a look at authentication methods in general. So you'll have a client. That client could be a human user, or it could be a machine or application. And this client needs to authenticate into the Vault server. Everything in Vault is path-based, so you're going to authenticate at a particular path. Depending on which authentication method you've enabled and you want to use. So as I mentioned before, there are multiple ones. But generally speaking, the response is the same. You're going to get a token back once you've logged into Vault with any one of those authentication methods. And associated with this token is a policy. So this token, once the client has it, can use it to talk to Vault and retrieve secrets from Vault. This token has a time to live, and it expires at the end of this time to live, and Vault no longer will respond to requests based on this token. The user or the client will need to re-authenticate to Vault to get a new token. The policy is the authorization mechanism into Vault. So once you've authenticated the policy, lets Vault know what you're allowed to do inside of Vault, what secrets you're allowed to retrieve, and so on. That's it for this lecture. I hope you liked it, and I will see you in the next one. In this lecture, we're going to discuss the types of auth methods. Let's get started. There are two broad categories of authentication methods. Either they are humans or user authentication methods, or application authentication methods. So the first category, methods for users, user pass, GitHub, LDAP or Active Directory, JOT, OIDC, and Okta. And the methods for applications are AppRole, which is similar to user pass, but for applications, AWS, Azure, Google Cloud, Ali Cloud, and Kubernetes. So keep those in mind. You may get asked in the exam on some of these or the differences between them, or which one would you use in which scenario. Enabling authentication methods. So most Vault auth methods need to be explicitly enabled, and this is done with the command vault auth enable. Each auth method has a default path. Remember, everything in Vault is path-based. You can also define an alternate path so that you can enable multiple instances of an authentication method. As an example here, you might have the Vault auth enable and then the flag path AWS East. And you might want to have one for East, one for West, depending on the use case. But once you do that, you start to need to use that custom path everywhere. So if you're writing configuration like this command, the vault write command that you see, you're going to need to use the AWS-East path as opposed to the default AWS path that you would have to specify. So keep that in mind when you are writing configs, when you're retrieving secrets or anything else within Vault, not necessarily with authentication methods. Whatever path you've defined is what you need to use moving forward. That's it for this lecture. I hope you enjoyed it, and I'll see you in the next one. So going back to our internal architectural diagram, you can see where the policy store lives right here, where we're storing policies. And really quickly, this diagram we saw in the authentication section, where there's a policy attached to a token. So Vault uses policies to govern the behavior of clients, also instrument role-based access control, or RBAC for short, by specifying access privileges with least privilege principle. We're always using we should always be using the least privilege principle when we're defining policies. And think of it as the authorization mechanism to access secrets. That's all what policies do. So back to this diagram, a client, whether a human or an application, authenticates into Vault based on a number of authentication methods, whichever we use. Basically, you get back a token and a policy attached to that token, and that policy is what authorizes the holder of this token as to what they can do inside of Vault, primarily accessing secrets. But of course, there are other endpoints within the policy that you can use for admin purposes. Very important to understand, it's a deny by default, so it's secure by default. So any empty policy equals not authorized. So if you don't have a policy, you're not authorized. Built-in policies, there are two built-in policies. Very important to remember this, specifically for the exam. There's the default policy and the root policy that are built in. Here's a table of kind of a comparison between the two. So the default policy, you cannot remove it, but you can modify it. Whereas the root policy, you can't remove it and you cannot modify it. The default policy is attached to all tokens. The root policy, any user that holds this policy becomes a root user. So think of it as a super user that can do anything inside of Vault. The default policy can be explicitly excluded at token creation time. So this command here, vault token create, with the flag no default policy, will remove the default policy from this token. On the root policy side of things, a best practice, I've mentioned this in a number of lectures and labs, is to revoke the root token in production. Vault token revoke, and then you put in the token. And on the default policy side, it allows basic functionalities such as letting the token look up data about itself and to use its cubbyhole data. And that's it. Whereas in the root policy side of things, the Vault server is first initialized. One root user is created to do the initial configuration and setup of Vault. After configured, the initial root token should be revoked, and more strictly controlled users and authentication methods should be used. So basically, it's a method to get everything set up in the beginning inside of Vault. This is the root token. After that, you revoke the root token, you create an admin policy for administrators, and then other policies for regular users and applications in the system. That's it for this lecture. I hope you enjoyed it, and I will see you in the next one. So back to our usual diagram for the internals of Vault. You can see the token store component right here. And tokens really are the core method for authentication within Vault. We've seen that a few times already in this course. And tokens can be used directly or dynamically generated by the auth methods. Clients need valid tokens to interact with Vault. And now let's take a look at this token store that we saw in the previous diagram. It's also referred to as the token authentication backend. It is a special auth backend. It's responsible for creating and storing tokens, and you can't disable it. It's the only auth method with no login capability. It's built in and automatically available at this path, auth/token. You can create tokens directly and bypass other authentication methods. It's not recommended to do that, although sometimes you may need to, but for the most part, it's better to use authentication methods, as we saw in the previous section. And from authentication methods, a token gets generated. Here's what it looks like in the Vault UI. You can choose the token authentication method, and then you put in your token and you'll log in. Now, this is what we've been doing with the root token all along throughout this course, but we'll get a little bit more deeper in this section. That's it for this lecture. I hope you enjoyed it, and I will see you in the next one. We're back to our diagram, and you can see where secrets engine lie in the architecture internals of Vault right here. Secrets engines are the component of the Vault architecture that manages secrets. As you can see here in this picture, this is a snapshot of all the secrets engines available to Vault at the time of the recording. So this is Vault 1.9.3. And we will cover the most popular secrets engines in this course. So secret engines, they store, generate, or encrypt data. They are enabled at a path. They're flexible and pluggable. You can even write your own secrets engine. And think of them in terms of their function. Some just store and read data. Others connect to external services and generate dynamic credentials on demand. Others provide encryption as a service. Also the timed one-time password generation. And finally, certificates. Now let's take a look at the life cycle of secrets engines. The first option here is to enable a secrets engine, and this enables it at a given path. Each secrets engine is isolated to its path. By default, they're enabled at their type. For example, AWS will be enabled at the path AWS. You can also customize the path, of course, for any of the secrets engines. The second option is to disable. So you can disable an existing secrets engine. When a secrets engine is disabled, all of its secrets are revoked if they support it, and all of the data stored for that engine in the physical storage layer is deleted. You can move the path for an existing secrets engine, and this process revokes all secrets since secret leases are tied to the path where they were created. The configuration data stored for the engine persists throughout the move. Finally, tune, and this tunes the global configuration for the secrets engine, for example, the time to live. Let's take a look at some commands. So if you run the vault secrets -h command or --help, you'll get the help under this particular subcommand, vault secrets. And the most common ones here is vault secrets list that you'll use quite often to find all the enabled secrets engines in Vault. Also, enabling a new secrets engine is vault secrets enable, and then the secret engine, in this case database. You can see the subcommands are similar to they are the ones that we saw in the previous slide. So disabling a secret engine, enabling it, listing all the enabled secrets engines, moving a secrets engine to a new path, and finally tuning a secrets engine configuration. That's it for this lecture. I hope you enjoyed it, and I will see you in the next one. When a customer or an organization starts to expand the usage of Vault across geographic locations, across data centers, across regions, that's where you want to start looking at Vault Enterprise. And the Vault Enterprise license can give you this ability to scale out. There are two main design considerations. There's the disaster recovery, as I mentioned, and performance replication. In this case, this is kind of a map of the United States. It could be that you have global regions, not just the United States. So what you want to do is put a performance replica cluster in each one of those regions. So if I have a west region, a central region, and an east region, I want to put a performance replica in each one of those regions. I will have a primary performance cluster, and inside that cluster you can see that we have 5 nodes, and we talked about high availability within a region before. And as you can see, I have performance replication across the regions, and then I have also disaster recovery clusters in each one of those regions as well. There are different considerations. You might want to have your disaster recovery cross regions as opposed to local to each region. Really depends on the architecture and what you're trying to achieve. But do understand that performance replication clusters are active clusters that you can talk to and they will respond to you. Whereas disaster recovery clusters are warm standbys. The only thing they do is that they receive replicated data from their primary clusters. Now, if an application needs to retrieve secrets from Vault, these applications need to talk to their local Vault cluster. That's really the reason why we call them performance replication or performance secondaries, for example, because the application doesn't need to cross a geographic region, let's say from the West Coast to the East Coast, to retrieve secrets, because that adds latency to the application. So once again, the East Coast applications will reach out to the East Coast Vault cluster. Now, a few things to note about performance replication and disaster recovery. For PRs, no dynamic secrets or leases or tokens get replicated over. So if, for example, this application logs in to Vault to retrieve secrets, and for some reason this cluster goes down, and this application has a mechanism now to talk to this Vault cluster, any dynamic secrets or any tokens, this cluster will not know about because they don't replicate across. So what will happen is that this application will have to re-authenticate into Vault and regenerate those dynamic secrets or leases. The KV store, all the data in the KV store gets replicated across. So if you're only using the static KV secrets engine, then you're okay. But for dynamic secrets, anything with a lease, then you have to take that consideration into account. And the reason for that is that, Vault encourages short-lived secrets, short-lived dynamic secrets. We don't want to encourage long-lived dynamic secrets. Now, when it comes to replication for disaster recovery, everything gets replicated in this case. So all the configs, the secrets, the leases, the tokens, everything gets configured or gets replicated over. And if the primary cluster goes down, then what you need to do is manually promote the disaster recovery secondary, and you'll find all your leases, your tokens, everything is there. The downside to this is that this is a manual promotion. You can write a script to speed up the promotion, but it's done on purpose because sometimes it's difficult to really determine if this cluster is down. It could be a hiccup on the network or something like that. So it's not so easy to figure out whether it's actually down. So human intervention is needed at this point. And you really need to determine your SLAs, your RTO, RPO, to figure out if you need both performance replication and disaster recovery, or if you want to start off with disaster recovery and add performance replication later. So again, depending on the SLAs, you can answer that question. Now, here's a comparison between DR and PR. You might get asked some of these questions on the exam. So for DR, it mirrors everything. So it mirrors the configuration of a primary cluster. So does the PR. When it comes to configuration of primary clusters, backends, auth methods, secrets engines, audit devices, all that gets replicated over for both DR and PR. Where they differ is when it comes to tokens and leases for applications and users interacting with the primary cluster. So yes for DR, no for PR. And again, secondaries keep track of their own tokens and leases. And when the secondary is promoted, applications must re-authenticate and obtain new leases from the newly promoted primary. Finally, for DR, it allows the secondary cluster to handle client requests. That's no. It's a warm standby. The application can't really interact with DR. Whereas with PR, it is an active cluster where the application or human users can interact with. So that's all I wanted you to take from PR and DR. That's pretty much what you need for the exam. Obviously, there's a lot more to this when it comes to architectural design. So if you're interested in getting a little more deeper, do take a look at the whiteboard session and the demo session in the next lecture. Thank you for watching, and I will see you in the next lecture. All right, so let's get started and understand a little bit about the Vault agent and why it came about. So the Vault agent is a client daemon that uses the same Vault binary. Same Vault binary that you downloaded before, you can use it for the Vault agent. It's used to easily adopt Vault without making code changes in your applications. Meaning that your application does not need to be Vault aware. So you don't really need to make changes to the code of your application. You can just utilize the Vault agent. Now, what can it do on behalf of your apps? So instead of writing code and functionality in your applications, the agent will help you with the authentication into Vault, and the feature here is called auto auth. It will also help you manage the token renewal process, also part of the auto auth functionality. From a caching perspective, it can do client-side caching, where it's going to cache the Vault tokens and also leases, so dynamic secrets. It will not, however, do caching for the key value secrets. And that functionality is caching within Vault Agent. It will also renew the cache tokens and the leases that it generated. Also, another very important feature is templates. So you can do templating, where you can write a template and Vault Agent will go grab some secrets, put it in the pre-configured template, and render a configuration file that your application can read from. And in there, the secrets are already populated. So again, the application doesn't need to know anything about Vault as long as it knows how to read from a particular file. And many applications know how to do that, like a config file, for example, then you're good to go. And this is how you run the Vault Agent. As you can see here, Vault Agent -config, and you specify the configuration file for the Vault Agent. That's it for the Vault Fundamentals course. Congratulations on completing it. I hope you enjoyed it. If you're looking to dig deeper into Vault, or if you're interested in becoming a certified Vault associate, then I recommend you check out my full 8-hour course called HashiCorp Vault 101 Certified Vault Associate. You'll find the link in the description of this lecture. I've also included a video talking about it in more detail in the next lecture.